So section 3.5 is on moles. Right? So a mole is a unit of counting. If I tell you that I have a dozen of something, it's like saying that it's the same as saying that I have 12. If I tell you that I have a gross of something, I'm saying I have 144. Moles are a unit of counting that we use in chemistry. They're a really big unit, though. A mole is 6.02 times 10 to the 23rd. So a mole of something is 6.02 times 10 to the 23rd of something. That's such a huge number that we can't really use it for physical objects that would be around us. 1 mole of paper would be just an astronomically huge amount of paper. But when we start talking about atoms and molecules, it's a really practical number. It's practical because of this relationship. So if I have something with a mass of 1 AMU, and I have 1 mole of that something, 1 mole of something with a mass of 1 AMU, will have a mass of 1 gram. Okay. So just for example, if I say that if I say that I have 1 mole of carbon-12 atoms, that will have a mass of 12.00 grams. Now, when we are looking at the periodic table, though, so basically, let me backtrack a little bit. When we look at the weight of molecules, we have to bear in mind that, just for example, if we were in the lab trying to measure out 1 mole of carbon, okay, we're dealing with a bulk sample of carbon, and we are going to have all the naturally occurring isotopes in there in the ratio where we would expect. So if I wanted to weigh out 1 mole of carbon, I would look on the periodic table and I would say that see that the average molecular weight is 12.01 grams per mole. By the way, that's the unit that I can stick on here now. So 12.01 grams per mole. And so if I want 1 mole of carbon, I need 12.01 grams of carbon. Right. Now, that's all good and well, but oftentimes we're dealing with compounds. So let's look at how we do that. Let's say that I have a methane molecule. Methane has a formula of CH4. We'll talk about where that name comes from in chapter 4. I look at this. I have 1 carbon. I have 4 hydrogens. Now, if I go to the periodic table and find my mass of carbon, I find that it's 12.01. Hydrogen, I find 1.01. Multiply these across, 12.01, 4.04, add them up, and I get 16.05 grams per mole for methane. All right, so let's say that I tell you I have a 22.93 gram sample of methane. Right? So 22.93 gram sample of methane. I want to know how many moles. So 22.93 grams, how many moles? We know that it's 16.05 grams per mole for methane. We calculated that. But I need to write this in a way that is going to cancel out grams and leave me with moles. So I'm going to write this as 1 mole over 16.05 grams. And if I plug that into my calculator, I find, pardon me while I actually plug that into my calculator. I find that this is 1.43 moles. All right. So let's look at this another way. Let's say that I want 0.621 moles of calcium carbonate. What would be the mass of that? Right, well, first thing I need to do is find my molecular weight. So I have 1 calcium, I have 1 carbon, I have 3 oxygens. And I look at the periodic table and I find the periodic table and I find that calcium is 40.08, carbon is 12.01, and oxygen is 16.00. Multiply this all through. And I get 100.09 grams per mole. Right. I have 0.621 moles times 100.09 grams per 1 mole. And I multiply this, I get 62.16 grams of calcium carbonate. Right. Now, let's look at one other way that we could look at moles. Let's go back to my 0.621 moles of calcium carbonate. I want to know how many calcium carbonates that is. Okay, so I know that I have 0.621 moles. I know that 1 mole is equal to 6.02 times 10 to the 23rd. So I can say 6.02 times 10 to the 23rd over 1 mole. And when I do that, I get 3.74 times 10 to the 23rd. Calcium carbonates. Right. So that's how we do that. And that covers us for chapter 5.